now I'm going to be introducing tangents, half angles. And of course, you're going to start seeing some not only different, but bigger. Okay? A lot of these you will start to see commonalities because of our reference angles. Okay, so you probably already see part A, but see if you can do part B as well. Good luck. Go ahead and try those. All right, hopefully you gave those an attempt, because the easy thing to do with half angle identities is just immediately multiply by that 2 over 2, that fancy one. And when you double the top, you will get your 45, and then multiplying across, you get the 2. That's where the half angle comes in. Okay, so you're just going to double that and then divide by 2 so it stays the same for each of these. So I haven't done anything with radians yet, just keeping it degrees for the first couple here. Now, you did have an option for tangent. There are 3, unfortunately, different identities that you could have used. So for the tangent of 45 over 2, I probably would have used the sine of my angle over 1 plus cosine of my angle. Now remember, the angle that we're going to be using is the 45, not the 22.5 or anything like that, even though that's what we're evaluating. And remember, if you use the first one, which had the plus or minus and the square root for tangent, then you're going to have to decide whether it's positive or negative for that angle, which for this one obviously should be positive, as with this one. So it's totally up to you. I'm going to use this one. I'll use another one for this, but if you want to try 2 or even all 3 to see if you get the same thing, that's completely fine. More power to you. All right, so I'm going to go ahead and plug in my angle of 45 degrees for each of those. Then I'm going to evaluate and simplify. So the next step would get, and now hopefully all of you that asked your teachers in high school, when am I ever going to use this in algebra? Now you see when and why. You learned what are called complex fractions. We have fractions within our big fraction. So I've shown you a couple different ways. I think the easiest way when you have common denominators is just to multiply by that fancy 1 of that common denominator. So in this case, I'm going to take this whole thing and multiply by 2 over 2. So on top, the 2's will cancel out, and I just get a square root of 2 as my new numerator. In the denominator, I'd have to distribute there to get a 2, plus distribute here, which would then cancel the 2's out on top and bottom, and I'd be left with root 2. Normally that would be a fine answer, but because there's a root on bottom, we're going to have to do one more algebraic thing, and that is multiplying by another fancy one we call the conjugate. So distributing through, you'd get 2 root 2 minus square root of 2 times square root of 2 is square root of 4, or 2. On bottom, I don't have to do the whole formula because we know they're conjugates. So this would be a positive 2 root 2. This would be a negative 2 root 2, so they'd cancel out. So we only have to do the first distribution, which is 4. And then the positive times negative would be negative. Square root of 2 times square root of 2 is 2. And notice all the roots are gone. So that would give me a final answer of 2 root 2 minus 2 all over 2, which, because this is being divided by 2 into each of these, and they're both even numbers, then I can divide by 2 to the outsides. Do not go inside the root unless you have a root in the denominator. So the final answer for this one will actually be the square root of 2 minus 1. All right, hopefully you were able to get that by doing this first one here. If not, go ahead and pause it and try part B now that you've seen me work one out. For the tangent of 75, we said we would first double it and divide by 2. So that's that 2 over 2 that we're talking about. And then that would also allow me to rewrite this as the tangent of a over 2. So again, there's 3 of them. I'm going to choose a different one than the one I used last time. So this time I'm going to use the one that has the cosine on top, which would be 1 minus the cosine of a over the sine of a. And that would then allow me to evaluate, because those are, even though it's in a different quadrant, a reference angle. You should know that because we know 180 less 30 degrees would be a total of 150 degrees. Okay? So these are just reference angles of 30 in quadrant 2. So one is going to be negative and one is going to be positive. So that would then yield, we know the cosine of 30 is root 3 over 2, but because we're in quadrant 2 actually, we're going to have a negative. Don't lose that negative. And then 30 degrees in quadrant 2 for sine is positive 1/2. So simplifying the top, that would become a positive. So we get 1 plus the square root of 3 over 2, all over 1/2. And since this one is being divided by 1/2, and we don't like to divide by fractions, I'll go ahead and just multiply by 2 over 1 to get rid of it. But remember, that has to be done to everything on top. So that would leave me with a 2, and then these 2's would cancel out to just be plus the square root of 3. So sometimes it pays to use one over the other. It's just a matter of sometimes luck or trying to see what's going to happen in advance, right? Not too bad, but again, lots of little nuances, places that you can make a mistake, especially with negatives, right? Be careful, pay attention to those, and then just make sure you evaluate correctly. Now, just to prove a point, let's go ahead and do this one more time, and let's use the sum or difference identity to compare our answer for that last one that we just did, the tangent of 75, which we got was 2 plus root 3. Let's see what we would get for that. So I'd rewrite it as 30 plus 45, and then rewriting that sum formula, tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. Then evaluating that would give me tangent of 30 is root 3 over 3, tangent of 45 is 1. So as you can see, that one worked out pretty nicely, but then we'd have to get our 1 to be 3 over 3 so that I could add the tops, and then that would leave me with, which then I can go ahead and multiply by the reciprocal of the bottom, which would be everything on bottom would cancel out, as would the 3's here. So we'd only be left with the square root of 3 plus 3 over the 3 minus square root of 3 on bottom. And because there's a root, we would have to go ahead and rationalize our denominator, which we're going to take this and one more time multiply by our fancy one of, we call it conjugate, 3 plus root 3. And that would yield 9, 3 root 3, and then another 3 root 3 to get 6 root 3's, and then a root 3 times root 3 is root 9 or 3. Bottom, 9 minus 3, which is 6. So cleaning this up, the 9 and the 3 together would equal 12, plus our 6 root 3, all over our 6, which now you can see we can divide that into each of these to get a final answer of 2 plus the square root of 3, which if you remember, that's exactly what we got here. But I know for a fact that that was a whole lot easier for this one than all of that was. So if you are given the choice, think ahead, think about which ones, as you've worked through these practice problems, are a little bit more conducive or simply just faster to your learning and getting to the end result. Okay? If they don't give you an option, then you're stuck with doing what they've asked. And in this one, you can see that they're asking us to find half angles for both sine, cosine, and tangent. But notice they didn't give us anything about that angle. They only told us that cosine of s, not s over 2, not half of s, but cosine of s is equal to something, and s is in this quadrant. So of course, let's give ourselves a visual. Let's draw that out. Where would that be located? Between pi and 3 pi over 2 in quadrant 3. we will have angle S, which we know gives us a negative value, and positive value for those. And because they did tell us what S is in terms of that, then since it's cosine, this is our X and this is our R, so -3 and 7. Which is that a Pythagorean triple? You wish. Not always, right? If this was a 3, 4, 5, cool. Or a 6, 8, 10, just doubled, they'll do that every once in a while as well. And or they'll give you one of the other ones. But in this case, we're going to actually have to use our Pythagorean theorem to find our y value. And remember, opposite the 90, the hypotenuse is always the one by itself. So our formula for the Pythagorean theorem will be, which gives us, and then has us taking the square root of 40, which is not a perfect square, but we have to put the plus and minus, and I'm going to leave 40 as 4 times 10, because I do know the square root of that, so that will be 2, and then the 10 will still be under the root. So 2 root 10. Now, is it positive or negative? Well, we already established that because it's going downwards. It's going to be the negative 2 root 10. And now we have everything we need for that angle S. But the problem is every single one of these parts, A, B, and C, wanted us to find S over 2. Does that mean we actually want to find S and then take half of it and then try to evaluate? No, we don't have to do all that work. We can actually just rewrite our half angle formulas for each sine, cosine, and tangent. So I'll do that now. So for sine, we don't have an option. Cosine, we don't have an option. But for tangent, we do. And I typically prefer, out of all three of them, the one that has just one thing in the denominator. Because then I can take that, whatever it is, and divide it into each, or get rid of the fraction by multiplying by its reciprocal. Okay? So our next step would simply be to evaluate the cosine of, notice it's S now, for all of these on top, and then for this one, the sine of S in the denominator. So doing that, I'd get the cosine of S. They actually gave me at the beginning. I didn't need to do any of this in order to evaluate the sine and cosine. But I did need it over here for that one, unless I would have chosen the other alternative form, which was tangent of S over 2 that had the square root on it. So you could have gotten away without doing any of this and just use what they gave us here for each one of these if you didn't want to use this one. Okay, your option, that's totally up to you. If you want to go through this, extra practice or whatever, just wanted to show you the different ways that you can do it. So since I already have this one set up, I'll go ahead and finish, but otherwise you could use the big square root with the 1 minus cosine S over 1 plus cosine S. All right, so I'm just going to plug those things in, which they, remember, gave us -3/7 as our answer. And then for sine, since we have this, remember that's the y over r, so that on here would be -2 root 10 over 7. Very, very ugly. We're going to have to clean these things up. And in order to do that, my next step would be getting my 1 to be a 7 over 7, so I have my common denominator, and then negative times negative became a positive, so I get 10/7 on top. Don't forget it's all over 2. And then over here, same thing, that 1 would become 7 over 7, and then this was a negative. So then 7 minus 3 is 4/7. Don't forget over 2. And then here, same idea, 10/7 on top, and then this was what was on bottom, which we'll deal with. So doing each one of these individually, it's totally up to you. If you want to do them all at once like this, just depends on the problem in the process. Okay, but now we got to clean these up a bit and then give them all the rationalized denominators with no roots in the bottom, so it's in its simplest form. All right, that would give us So now we have the positive and negative of the square root of 5 over 7, which is all under the root, 2/7 under a root, and then negative 5 over root 10. And that was just by multiplying by the reciprocal to both top and bottom, my 1's, to get a bunch of stuff to cancel out and get simplified. But our last step would obviously be to get rid of the roots in the denominator. So I'm going to have to multiply this one by a fancy one, square root of 7 over 7. Same with this. And then this one, square root of 10 over square root of 10. Now, that still leaves me with the positive and negative case. Multiplying this, since they're both roots, I can keep it underneath. And then that would be a 7. This one, same thing. That would give me the square root of 14 over 7. And then this one would give me negative 5 root 10 over 10. So one more step there. So my final answers would look like positive or negative, square root of 35 over 7 here, positive or negative, square root of 14 over 7 there. Remember, the bottoms do not have roots on these, so do not try to cancel it with a root on the top. And then this one, these were on the outside, so I could cancel that 5 and that 10 by 5. So the final answer for that one would be negative square root of 10 over 2. Now this one I can circle, box, and put in my final answer because it has the negative. But these ones we would still have to figure out where they are. Now we definitely know they're not in quadrant 1 because something came out negative, and that was our tangent. So you can use that to your advantage, or just take what they told you. This relationship here with these inequalities, and remember we were trying to find what s over 2 was, not s, which they gave us the information about. So since we're trying to find what s over 2 is in all of these, and we need to figure out if they're positive or negative, then all we have to do to this entire thing is to keep it equal, divide everything by 2, or cut it in half. And that would give us the scenario of each of these things being half as big. So we know it would have to be between pi over 2, or s over 2 would be, or the other one was 3 pi over 4 now. And where is that located? Well, we know pi over 2 is at 90 degrees, but where is 3 pi over 4? Well, you know pi over 4 is 45, and we'd have that 3 times. So that would be 1, 2, 3 pi over 4s. So our angle s over 2 is right there, which would be in quadrant 2. So the sine would be positive, and everything else should be negative, which we already found for tangent. Okay, so long process, a lot of little things, but remember I actually did 3 problems in one just to give you an example of each. Sine half angle, cosine half angle, and tangent half angle, if they ever give you a scenario like this. All right, and remember this one I did more work than I actually needed to do because I could have just used the one that had the big square root and still figured that one out by doing what we just did with just our cosine on top and bottom. All right, not too bad, but again, a lot of little nuances, a lot of little things that you learned in algebra that you now have to apply in this class. So here is our 4th and final example. Now they just want us to, given an expression, simplify it. Okay, and I gave you a little bit of a hint to be careful and pay attention to the details. Did they give you exactly what you wanted, the way you wanted it? If so, great. Recognize that it is identical or equal to something and write it down. What is this equal to? What is this equal to? And then just do what they asked. Simplify. So go ahead and pause it, see if you can do these. If you need to use your notes, by all means, you're just learning this stuff right now. All right, hopefully you gave those a chance. They're not that difficult, actually. These ones are easier than the last video where we had to multiply by some fancy ones. These are given to you in the form that you already needed. So this is our plus or minus square root of 1 plus cosine of an angle all over 2, which means you just need to recognize which one that is. Is that the half angle? As soon as you see plus or minus square root, you know it's a half angle. For sine, cosine, or tangent. And hopefully you said this is equivalent to cosine. You just got to recognize what half of what angle you're going to be taking. And the angle that they gave us was 12x. So that's what you should then be putting in here. And then actually taking half of it. So we get cosine of, that becomes 6x. If you want to keep the parentheses around it, you can. Otherwise, there is nothing else you can do to simplify that. So you're done. That's it. It's that simple. Okay, don't make some of these harder than they have to be. Just recognize what they've given you is a half angle identity. So this is equivalent to this. We just simplified to get that. All right. Part B, hopefully you recognize, does not have a square root. Therefore, it can't be the sine or the cosine. And hopefully you're looking to see if it's the tangent. Is it one of the tangent ones? Did we have 1 minus cosine of an angle over sine of an angle? Hopefully you recognize that. I just did it in the previous example. So yes, this is a tangent half angle formula. And the angle they gave us this time is 5 alpha. So we would be taking that angle and putting it there. Now, is there anything that we can do with that? No. So my final answer is simply the tangent of 5 alpha over 2. All right, and then part C, which one is this? Well, over here it was 1 plus, and remember the signs were the same. If it was cosine plus, then we knew it was the cosine. The opposite would be the sine. So for this one, yes, it is indeed the half angle formula for sine, and this time the angle is obviously 8x. So our final answer here is going to be half of 8x, which is 4x for sine. Again, if you want to put the parentheses, fine. If not, no troubles. Okay, that's it. Make sure you practice these. They can be tricky. Pay attention to your signs and your quadrants. And most importantly, know your reference angles and their values. And then finish with all your algebra techniques. Multiplying by ones, getting common denominators, things of that nature. And being careful with the square roots and making sure that you figure out whether it's a positive or negative answer. Until the next time, that's it. Take care. Alan out.